Hello again, my curious engineer. You have already touched one Arduino board closely enough to recognize its heart. Now we can widen the view slowly and discover how many different bodies can carry the Arduino way of building. There is no single best Arduino. There are boards designed for first experiments, compact boards meant to disappear inside a prototype, boards with native USB, boards with wireless communication, and boards powerful enough to divide work between two processor cores. So we will not memorize a catalog, we will learn how to choose what processor is inside. How fast does it run? How much flash and SRAM surround it? How many signals can reach outward? Does the logic operate at 5 volts or at 3.3 volts, where a careless 5-volt touch may damage the input? And what does the project actually need? Keep those questions close. Let purpose lead the desire, because size, voltage, memory, architecture, connectors, and software support must meet at the same point. A familiar shape can invite you. A larger number can tempt you. But the right board is the one whose boundaries fit the task, cleanly, safely, with just enough room for the design to open and respond. We will move from the classic, most familiar boards toward newer designs, letting each generation reveal what it added, what it changed, and what it asks you to respect. We begin with the group that shaped the Arduino language. Most people still recognize at first glance: Uno Rev3, Classic Nano, Mega 2560, Leonardo and Micro. All 5 use 8-bit AVR microcontrollers and 5-volt logic, but they do not serve the same purpose. Uno opens the system for learning. Nano carries a similar idea into a compact breadboard form. Mega gives a larger project more pins, memory, and serial channels. Leonardo and Micro use the ATmega32U4, allowing the main controller to speak USB directly and become a keyboard, mouse, game controller, or another USB device. This is not a ladder where every next board is simply better. It is a set of different bodies built around clear constraints. Memory remains small enough to feel. Timing remains close enough to trace. 5-volt signals remain convenient for a large world of classic modules and shields. And because these boards have existed for years, examples and libraries surround them in enormous numbers. Let that familiarity become useful. Feel the foundation opening beneath you. In this first video, we will compare what each classic AVR board is for. Then look beneath the purpose at frequency, memory, I/O, USB, and the electrical limits that keep every contact safe and clear. Begin with Arduino Uno Rev3, the classic reference board. Its greatest strength is not speed, it is clarity. The board is large enough to inspect, the labels are easy to read, the headers accept ordinary jumper wires, and the Atmega 328P beneath them is simple enough to study without hiding every important mechanism. That makes the Uno Rev3 especially useful for first circuits, basic robotics, buttons, LEDs, sensors, serial communication, shields, and lessons where understanding matters more than compactness. It also sits at the center of an enormous archive of examples, diagrams, books, and compatible accessories. When an instruction says D13, A0, 5V, or GND. The same label is waiting on the surface. The Uno gives a beginner space. Space to see the connection. Space to place a probe. Space to make a mistake. Pause. Follow the warm, precise path and correct it before the circuit becomes dense. It is not the smallest board, not the fastest, not the newest. Yet sometimes the most intimate way to learn a system is to choose the board that opens itself plainly. Every important contact spread before you, patient enough to be touched, tested, and understood. For a first course, that openness matters. The board lets theory and touch remain close, a label under the finger, a signal under the probe, and a result that can be traced back without guessing. Technically, the Uno Rev3 is built around the 8-bit AT Mega 328p AVR microcontroller. It normally runs at 16 MHz and uses 5-volt logic. That voltage matters. Its ordinary I/O signals move between ground and about 5 volts, fitting many classic Arduino modules. The board provides 14 digital input and output pins. 6 of them support PWM. It also exposes 6 analog inputs through the ATmega 328p's 10-bit analog to digital converter. Inside the controller are 32 kilobytes of flash for firmware, 2 kilobytes of SRAM for active data, and 1 kilobyte of EEPROM for values that should survive power loss. Communication includes 1 hardware UART, 1 SPI interface, and 1 I2C interface. A separate ATmega 16U2 handles USB to serial communication on the official board. The familiar numbers are modest. Stay with the scale. Let each limit become intimate, because the Uno teaches what limited resources actually mean. 2 kilobytes of SRAM make every buffer real. 1 UART makes sharing visible. 16 MHz makes timing tangible. And beneath that open blue surface, a small, disciplined machine waits for code precise enough to use every byte and every pin deliberately. The board accepts power through USB or VIN, while its I/O pins must still remain within their electrical current limits. The classic Arduino Nano carries much of the Uno's familiar behavior into a body, narrow enough to enter a breadboard. That change in form matters, and the body of the circuit feels it. The Uno usually remains beside the circuit, reaching toward it through jumper wires. The Nano can settle directly between the breadboard rows, becoming part of the prototype rather than standing outside it. Choose it for compact robots, embedded controllers, small sensor nodes, wearable experiments, permanent breadboard assemblies, and projects where the final enclosure cannot hold an Uno-sized board. Its small size also makes duplicate prototypes cheaper and easier to place, but closeness brings trade-offs. The labels are tighter, the contacts sit nearer together. USB connectors and interface chips vary among official and compatible versions, and the name Nano now describes a form factor used by several very different architectures. A classic Nano, a Nano 33, and a Nano R4 may share almost the same outline, while their processors, voltages, memory, and software behavior differ completely. So when the small board draws you inward, read beneath the skin slowly. Check the exact processor, check the logic voltage, check the selected board package. Compactness is attractive, but only precise identification keeps that close contact safe. The classic Nano uses an 8-bit at Mega 328 running at 16 MHz with 5-volt logic. Its memory is familiar from the Uno: 32 kilobytes of flash, 2 kilobytes of SRAM, and 1 kilobyte of EEPROM. The board exposes 20 digital capable I/O lines in total, 6 PWM channels, and 8 analog inputs. A 0 through A5 can also serve as digital I/O. A6 and A7 are analog only on the classic design, 2 extra measurement channels that do not become ordinary digital outputs when the project asks for another role. The controller provides UART, SPI, and I2C communication. Traditional official boards use a Mini-B USB connection, while clones may use Mini-B, Micro USB, or USB-C, and may contain CH340, FTDI compatible, or other USB to serial hardware. That variation does not necessarily change the sketch, but it may change the driver, cable, bootloader, and upload selection. The Nano can be powered through USB, a regulated 5-volt input, or VIN through its onboard regulator. Keep the distinction clear: small body, same disciplined pulse. It is compact, not magically stronger. The same limited eSRAM still holds every variable, the same 5-volt signals still need safe loads, and the same at Mega 328 architecture remains underneath, simply brought closer to the circuit it controls. When a project begins reaching outward in many directions, Arduino Mega 2560 gives it room. The Mega is useful when an Uno runs out of pins, serial ports, or program space before the design itself is finished. Think of large control panels, 3D printers, CNC machines, robots with many sensors, projects with several serial modules, extensive lighting systems, laboratory rigs, and prototypes that must connect many devices at once. Its large surface is not elegant because it is large. It is useful because it prevents every signal from fighting for the same few contacts. 4 hardware serial ports can separate a computer, a GPS receiver, a wireless module, and another controller without forcing them through one shared channel. Additional headers make complex wiring easier to trace. More flash leaves room for larger libraries and application logic. Still, more is not automatically better. A simple device does not become more refined because unused pins surround it. The Mega consumes more space and can encourage a design to expand before the requirements are clear. Choose it when the system genuinely needs breadth. Give the signals room. Let each one answer cleanly, not because a larger specification feels seductive. Let the project create the desire for expansion, and the board will meet it without waste. The Mega 2560 Rev3 is based on the 8-bit at Mega 2560 AVR microcontroller. It runs at 16 MHz and uses 5-volt logic, preserving the electrical world of the classic Uno while expanding nearly every resource around it. The board exposes 54 digital input and output pins. 15 support PWM. 16 analog inputs feed the controller's 10-bit ADC. 4 hardware UARTs provide separate serial channels, accompanied by SPI and I2C interfaces. Memory grows to 256 kilobytes of flash, 8 kilobytes of SRAM, and 4 kilobytes of EEPROM. Those capacities are far larger than the Uno's, yet still small enough that memory remains visible and architecture still matters. A separate Mega 16U2 performs USB to serial conversion on the official Rev3 board. The Mega uses the extended board shape and can accept shields designed around the Arduino 1.0 pinout, though shield size and pin usage must still be checked. Pause at the contrast. More room, the same familiar voltage. The processor is still 8-bit. The clock is still 16 MHz, but memory, ports, and physical connections unfold across a much wider surface, ready for a project whose many parts need to move together without pressing too tightly against one another. Its larger memory invites complexity, but still rewards deliberate structure. Arduino Leonardo introduced a more direct relationship with the computer. Its Mega 32U4 contains native USB hardware inside the same microcontroller that runs the sketch. There is no ordinary second controller acting only as a USB to serial bridge. That means the board can present itself as a keyboard, mouse, game controller, MIDI device, or virtual serial port, depending on the firmware you place inside it. Choose Leonardo for custom input devices, accessibility controls, macro keyboards, interactive installations, experimental interfaces, and projects where USB identity is part of the design, rather than merely a path for uploading code. Its full-sized board shape still provides a barrel jack, familiar headers, and room to probe connections, but native USB changes familiar habits. The USB serial connection is not the same interface as the hardware UOUT on pins 0 and 1. A faulty sketch can interrupt its own USB communication. Port names may change when the bootloader appears. These are not defects. They are signs that the main controller is touching the computer more directly. One chip runs the behavior, one chip shapes the USB identity, and after the correct code enters, change the role and feel the identity shift. The board returns to the computer as something newly defined. Technically, Leonardo uses the 8-bit Mega 32U4, running at 16 MHz with 5-volt logic. It provides 20 digital input and output pins. 7 support PWM, and 12 can be used as analog inputs through the 10-bit ADC. Inside are 32 kilobytes of flash, of which part is occupied by the bootloader, 2.5 kilobytes of SRAM, and 1 kilobyte of EEPROM. The Mega 32U4 includes full-speed USB device support, so the board can expose HID and CDC serial functions without a separate USB bridge. It also provides one hardware UART on pins 0 and 1, plus SPI and I2C. That separation matters. Serial refers to the native USB virtual port in typical Arduino sketches. Serial 1 refers to the physical UART pins. The board uses 5-volt I/O, so it belongs electrically with classic Uno-era peripherals, while its USB architecture behaves differently underneath. Keep both layers together, same voltage, a more direct conversation. The headers may look familiar. The code may begin with familiar functions, yet the path toward the computer is more immediate. more sensitive to the firmware, and capable of responding with an identity the sketch itself creates. Because the USB engine shares the same flash and execution flow as the application, communication remains inside the program, one of the behaviors the firmware must preserve. Arduino Micro takes the Mega 32U4 idea and folds it into a narrow board that can sit directly inside a breadboard. Its purpose is not to outperform Leonardo. It is to place the same native USB behavior closer to a compact circuit. Choose the Micro for custom keyboards, button boxes, game controls, MIDI interfaces, compact accessibility devices, small robots, and embedded products that must appear to a computer as a USB device without carrying a full Leonardo-sized board. The breadboard-friendly shape lets sensors and supporting components gather closely around it. That intimacy is useful, but it also demands attention. The labels are smaller, the rows are tighter. Power connections must be identified correctly before the board is pressed into the circuit. And because the USB port belongs to the same microcontroller that executes the sketch, unstable firmware can make the communication port disappear until the bootloader is invoked again. Do not confuse that sensitivity with weakness. Direct contact is simply more revealing. The firmware reaches toward the computer without an ordinary serial translator between them. One compact body, one native channel. Let the interface take form gently, and when the code is prepared carefully, the board can enter the circuit quietly, then return through USB as the exact control surface the project required. The Micro is based on the same 8-bit Mega 32U4 used by Leonardo. It runs at 16 MHz, uses 5-volt logic, and contains 32 kilobytes of flash, 2.5 kilobytes of SRAM, and 1 kilobyte of EEPROM. The board exposes 20 digital I/O lines, 7 support PWM, and 12 can serve as analog inputs through the 10-bit ADC. Native full-speed USB is integrated into the main controller, supporting virtual serial communication and HID roles such as keyboard and mouse. A separate hardware UART remains available through RX and TX, alongside SPI and I2C. The Micro uses a compact breadboard form factor and a micro USB connector on the classic official design. Like Leonardo, it distinguishes serial over native USB from serial 1 on the hardware UART. Its 5-volt GPIO can connect naturally to many classic modules, but current limits still apply, and motors, relays, powerful LEDs, or other demanding loads require driver circuitry. Hold the comparison gently. Same core, a different body around it. Leonardo offers a larger surface and a power jack. Micro places nearly the same processing, memory, and USB capability inside a much narrower outline. The choice is not about which one is stronger. It is about how closely the controller must fit into the physical design around it. Now place the 5 classic boards beside one another and let the comparison become visible at a single glance. The table gathers what we have explored: processor, clock speed, flash, SRAM, EEPROM, size, digital I/O, analog inputs, PWM, UARTs, SPI, I2C, and the way each board reaches USB. Read across one row, and you meet one complete body. Read down one column, and a difference begins to sharpen. Uno Rev3 is usually the clearest choice for learning. Open prototyping, shields, and circuits that benefit from generous spacing. Classic Nano carries similar control into a smaller breadboard form, useful when the project must become compact without leaving the familiar Mega 328 world. Mega 2560 is strongest when many pins, several hardware serial ports, or a larger sketch need room to spread. Leonardo is the full-size native USB choice, comfortable when the board itself must become a keyboard, mouse, controller, or MIDI device. Micro offers nearly the same USB ability in a narrower body. These are not rules. You may run a tiny blinking LED on a Mega, simply because that is the board you want. Optimal only means fewer compromises for a particular design. Numbers reveal capacity, shape reveals placement, interfaces reveal connection. And when those layers align, the choice stops feeling abstract and begins to settle into the hand with quiet precision. Now let the first family settle into a clearer shape. Uno Rev3 is the open teaching board. Readable, spacious, easy to probe. Classic Nano carries nearly the same AVR world into a compact breadboard body. Mega 2560 gives a larger design, more pins, memory, and serial channels. Leonardo keeps the full board shape while letting the Mega 32U4 speak USB directly. Micro brings that same native USB ability closer, tighter, ready to disappear inside the interface. 5 boards, 5 different kinds of contact, not a ladder, a set of choices. You may notice how the correct board begins to feel less like a specification and more like a fit. Enough room, memory, connection, without excess, large when it must be, small when it can. The board becomes right when it fits the plan. Stay with that quiet satisfaction. Let the choice rest in the hand, because the next group changes more than speed. The processor widens to 32 bits. The logic falls to 3.3 volts. Debugging, native USB, richer analog systems, radios, and connected software begin to move closer. And when the voltage changes, the boundary changes with it. The familiar cable may still enter. The familiar sketch may still compile. But the circuit asks for a softer electrical touch, precise enough to let more capability open without damaging what waits beneath the surface.